Hello, everyone, and welcome to this interesting session on machine learning projects, where I'll guide you through the various ML projects one can take up and what are the trending products in the industries and the latest advancements this domain has made in the past few years. Not only this, I'll be showing you guys some use cases of supervised, unsupervised, as well as reinforcement learning and how these machine learning algorithms help us in solving the real life scenarios and creating profits for these companies. But before we move ahead, let's understand what exactly is machine learning in brief and what are its various types. So machine learning is a concept which allows the machine to learn from examples and experience, and that too without being explicitly programmed. So instead of you writing the code, what you do is feed the data to the generic algorithm, and the algorithm or the machine builds the logic based on the given data. Now, typically, any machine learning algorithm has some steps which it needs to follow. So what now I'm going to discuss are the generic steps what every machine learning algorithm follows. So the first stage involves the collection of all the relevant data from the various sources. After collecting the data from various sources comes data wrangling, which is the process of cleaning and converting raw data into a format that allows convenient consumption. After that, data is analyzed to select the filter and filter the data required to prepare the model. And after that, the algorithm is trained on the training dataset, through which the algorithm understands the pattern and the rules which govern the data. Now, after training the algorithm, next comes testing. So the testing dataset determines the accuracy of the model. Now, if the speed and the accuracy of the model is acceptable, then the model should be deployed in the real system. After the model is deployed based upon its performance, the model is updated and improved. And if there's a dip in the performance, the model is retrained. Now, machine learning is subcategorized into three types. These are the supervised, unsupervised, and the reinforcement learning. So supervised learning is the one where you have input variables x and the output variable y, and you use an algorithm to learn the mapping function from the input to the output. Now what happens sometimes the given data is unstructured and unlabeled, so it becomes difficult to classify the data into different categories. So unsupervised learning helps to solve this problem. Now this learning is used to cluster the input data in classes on the basis of their statistical properties. And reinforcement learning is all about appropriate action in order to maximize the reward in a particular situation. Now, when it comes to reinforcement learning, there is no expected output, and the reinforcement agent decides what action to take in order to perform a given task. In absence of a training dataset, it is bound to learn from its experience. Now, the past year has been a great one for artificial intelligence and machine learning. Many new high impact applications of machine learnings were discovered and brought to light, especially in healthcare, finance, speech recognition, augmented reality, and the more 3D complex and video application. So first of all, let's discuss a use case which is based on supervised learning. The domain of this use case is going to be media, and the focus of this use case is going to be optimize the selection process. So let's understand the business challenge first. So Motion Studio is the largest radio production house in the whole Europe. Now their total revenue is more than $1 billion. So the company has launched a new reality show which is known as the Star RJ. And the show is about finding a new radio jockey who will be the star presenter on upcoming shows. Now, in the first round, participants have to upload their voice clips online, and the clip will be evaluated by the experts for selection into the next round. There is a separate team in the first round for the evaluation of male and the female voice, and that is where you lie. Now, response to the show is unprecedented, and the company is flooded with the voice clips. Now you as a machine learning expert have to classify the voice as either male or female so that the first level of filtration is quicker. Now the key issues to note here that the voice samples are across accents, and the output of the pre-recorded WAV files, which are the audio files, were saved into the CSV files. Now here we are going to take a data volume of around 3000 records for your understanding, and we're going to use the voice classification.csv data. The business benefit of this is that since the Star RJ is a reality show, the time to select the candidates is very short. The whole success of the show and hence the profit depends upon quick and smooth execution. So let me just open a Python 3 file. So let me name it as ml-projects. So first of all, what we're going to do is import the usual libraries. So as you can see here, we are importing pandas as pd, numpy as np. We are importing the matplotlib.pyplot. We are also going to use cborn. Once again, we are going to import warnings to suppress all the warnings which we get So let me just run it. Now the dataset is the voice data, and this database was created to identify a voice as a male or female. Now, based upon the acoustic properties of the voice and speech, the datasets consist of 3,800 recorded voice samples. And the voice samples are pre-recorded by acoustic analysis using the C-Wave and the tuner packages. Let's use the pandas to read the driver data.csv as a data frame called df. Here I'm going to use pandas to get the data, and let's have a look at the data. As you can see here, the data has 21 columns, which is the mean frequency, standard deviation, median. We have the Q25, which is the first quantile, and Q75, which is the third quantile. Here's Qness, kurtosis, the centroid, mean, minimum, maximum. Now let's have a look at the number of records. So it should be around 4,000. So it's 0 to 3,167. And as you can see, it has total 21 columns. All those columns are here. Now let's check the basic distribution of the data to understand the data in a much more deeper way. So as you can see here, we get the count, the mean, the standard deviation, the minimum, the 25, 50, and the 75th quantile, and we get the maximum value for each of the columns. So as earlier I said that we have to look for irregularities in the data. So next what we're going to check is that if there is any null values in any of these columns. So as you can see here, there are no null values or any missing values. Next what we're going to do is get the shape and the distribution of the data. So for that we're going to use the df.shape, and let's have a look at the data. It has 3,168 rows and 21 columns. And the total number of labels, we have the total number of males and the total number of females. So that we can determine with the label female and the male. Now another way to get the data shape is through this one also. So as you can see here, as Y is our output and X is our input, so the X shape is 20 columns. So as the last column is our output or the expected output. So what we're going to do is convert the label column, which is the male and the female, to 1 or 0 for easy encoding. So what we're going to do is from sklearn.preprocessing, we're going to import the label encoder. So we're going to create Y as the last column. We're going to get all the rows except the last column. Now we're going to get the data of all the rows, all but the last column. So the last column is going to be the output, which is the Y. And then what we're going to do is perform the label encoding on Y as well. So next what we're going to do is scale the data to be between -1 and 1. Now I'll tell you why we are doing this later on. So we're going to import the sklearn.preprocessing and standard scaler, and we're going to fit the X into the standard scaler transform. Now after that, what we're going to do is train, test, split. We're going to split the data into a training set and a testing set. So from sklearn.model selection, we're going to import the train, test, split, and we're going to split it. We have the X train, X test, Y train, Y test, and we're going to split it in the test size of 0.3. So that implies that 30% is the testing size, whereas the rest 70% is the training size. Now what we're going to do is next comes training the model. So it's time to train a support vector machine classifier. We're going to use a support vector machine here, which comes under supervised learning. So what we do is call the SVC model from sklearn and fit the model to the training data. It's as simple as that. So these are all the default hyperparameters which I'm going to set, and for this particular SVC model, what we're going to do is get the model evaluation. We have to get the predictions from the model and print the accuracy and create a confusion matrix and a classification report. So how do we get the accuracy when default SVC model is used? So what we do is use the metrics function, and inside that we have the accuracy score. So as you can see, the accuracy of the model, what we have trained here is 97%. We're going to create the confusion matrix for better understanding. So as you can see, the precision and recall and the F1 score and the support values here. So as you can see, our model is doing quite good. Now let's see if we can tune the parameters to try to get even a better result, which is very unlikely, and you probably would be satisfied with this result in real life because the data set is quite small here we took. But the idea here, what I'm going to show you, is the practice of using the grid search. So for that, what we're going to do is import the grid search CV from sklearn. But the question arises, does grid search improve the score? Next, what we're going to do is create a dictionary called param_grid and fill out some parameters for C and gamma. Now, if you want to learn in deep about all of these algorithms, do check out our machine learning full course video. I'll link the video in the description box below. So do check it out, guys. It's an amazing video. So let's continue this. So what we're going to do next is create the training and testing. We have already split the data. So what we're going to do is just use the grid fit. So as you can see, the C and the gamma values, the gamma has changed to 1. It's 0.01 again. This one again. As you can see, the value of C is 100. Now next that the model is done, and let's create some predictions using the test set and create the classification report and the confusion matrices for them. So let's see where we're able to improve the model in any way. So as you can see, the accuracy is 0.974. Let's check. As you can see, the accuracy here was 0.9737. We have 9747 here, so just a little ahead of the SVC model which we created. Sometimes the grid search may give you a better result than any other supervised learning algorithm, in this case the SVC, but it's usually not the case. So what you need to do is check for both the algorithms, as it does not take a lot of time, as you can see, to train thousands and thousands of data. And all you need to do is import all the algorithms from the sklearn library. So as you can see, our model was 97% accurate, and we were able to distinguish between the male and the female voice. So this model is very good, and hence we can get a better result from this one. And the business benefit, what I told earlier, was that there is very, as the Star RJ is a reality show, the time to select the candidates is very short. And the whole success of the show and hence the profit depends upon the quick and smooth execution. Now coming to the second use case we have here is of the domain of automotive. So our focus here will be on incentive drivers. Now lithium power is the largest provider of electric vehicle batteries. It provides battery on a rental model to e-vehicle drivers. The drivers rent battery typically for suppose a day and then replace it with a charged battery from the company. Now lithium power has a variable pricing model based on the driver's driving history. As the life of a battery depends on factors such as overspeeding, distance driven per day, and many other factors, you as a machine learning expert have to create a cluster model where drivers can be grouped together based on the driving data. Now the key issues here are the drivers will be incentivized based on the clusters, so grouping has to be accurate. We have the data stored in a driver data.csv file, and if you have a look at the fields here, so we have the unique ID of the driver, we have the mean distance day, which is the mean distance driven by the driver per day. We have the mean overspeed percentage, which is the mean percentage of the time our driver was above 5 miles per hour, the speed limit. Now the business benefit here is that increase in the profits up to 15 to 20%, as the drivers with poor history will be charged more. So that will help the company to increase the profit and reduce any loss by giving the same prices to every driver. Let's see how we can solve this problem using unsupervised learning. So what we're going to do is import the usual libraries, and I'm doing it in the same notebook. Here we have used the sns.set for plot styling, and we import filter warnings ignoring. Now, for the sake of simplicity, we take only two features, which is the mean distance driven per day and a mean percentage of the time the driver was 5 miles per hour over the speed limit. Now, first of all, let's get the data in the data frame using pandas. So as you can see here, we have the first 5 data. Let's check the number of records we have here. So we have 0 to 3099, that's 4000. We're going to describe the data set. So we have the ID, mean distance data. We again get the count, the mean, the standard deviation, the minimum value, the 25th, 50th, and the 75th quantile, and then the maximum value. So here we are using the k-means clustering algorithm. So what we're going to do is from sklearn.cluster, we're going to import the k-means. And then what we're going to do is create an instance of a k-means model with 2 clusters. Now, an important thing in k-means is to decide how many clusters you're going to make. So for simplicity, we're going to take 2 clusters here. So now what we're going to do is fit the model to all the data except for the ID label, because ID is not required for clustering. So as you can see here, we have the cluster centers. So next what we're going to do is check the labels of the data input. Now, we have to check the size of the label and it should match the dataset count. So as you can see, it matches the 4,000, which is the total data count. Now to know the number of drivers in the first and the second quarter, we have to find out. Let's see how we can do that. So we're going to use the k-means label and we're going to use the unique function. So as you can see, we have 800 and 3200. Now what we're going to do is plot the cluster and see what is the inference you can draw. So with that, we're going to plot the data and we're going to use the sns.set for styling. As you can see here, the data what we have is somewhat a little bit arbitrary. So what do you think, guys? I think the number of clusters should be 4. So let's see if we take the number of clusters as 4 and see the output. As you saw initially, we had 800 and 3200. That's a pretty huge difference we have here. So let's see how much more we can classify. So as you can see, we have 2700, 600, 400, and 100. Again, let's plot this particular model which has 4 as a number of clusters and see what we can infer from this one. So as you can see now, you see the data is evenly clustered and has a particular area where it is defined. So the company can make profit now by looking at the distance traveled per day. The driver who travels the maximum and which has the lowest overspeeding limit will get the maximum discounts, whereas the drivers who drive slow and have done a lot of overspeeding will have to pay more for the batteries. Now let's move to another use case, which is of the domain logistics. So our focus will be finding optimal path. Now BlueX is a leading logistic company in India and it is known for efficient delivery of packets to customers. However, BlueX is facing a challenge where its delivery vans are taking up suboptimal path for delivery. This is causing delays and a higher fuel cost. Now you as a machine learning expert have to create a machine learning model using reinforcement learning so that the efficient path is found through the program. Now the key issues here are the data has lots of attributes and the classification could be very tricky. Reinforcement learning is tricky, so the expectation is to come up with a sample flow and full-fledged implementation will be done by the team later. We'll have to hard code the sample data. If we talk about the business benefits, up to 15% fuel cost can be saved by taking the optimal path. So this is a very important thing or a very important concern for the whole company, which is the BlueX. So let's see how we can implement the same using the reinforcement learning method. Let's just import the required libraries first. We're going to use the network X library here and the PyLab. Now these are the points on the route which one driver can take. Now the driver has to go from 0 to 7. So let's plot a node graph for all of these points and see what we can infer from this. Now what we're going to do is create a matrix for the number of points in the graph. So in this case, we're going to use 8. So let's define the number of points first. It's going to be 8. Now what we're going to do is create a matrix X into Y. So for that, we're going to use the np.matrix method. Now next what we're going to do is assign values to the path and points so that the optimal path is chosen. So we're going to assign 0 to the path and 150 to the goal point, and this is how Q-learning works. And if you have a look at the R matrix here, so as you can see here, it's -1 and 0 and 150. So -1 does not provide you any value because that's paths you cannot take directly. So now in the above matrix, what you see here, the y-axis is the state or where the driver is currently located, and the x-axis is your possible next action. When then we build our Q-learning matrix, which will hold all the lessons learned from our driver, the Q-learning model uses a transitional rule formula, and gamma is the learning parameter. Now, if you want to know more about reinforcement learning and Q-learning, do check out our machine learning full course video, or we have a separate video for reinforcement learning as well. So do check it out, guys. I'll leave the link to those videos in the description box below. So as you can see here, we're gonna use the learning parameter, the gamma, which is 0.8, and we're gonna define the available actions, which is the current state, the next state in which we can do the returning. So this is how we calculate the Q values. Now I'm not gonna go into the details of it. If you have another video for it, it's usually the R current state and action plus gamma into the maximum value which you get from all the possible paths you can take to maximize the output. So let's update the Q values. what we're going to do is use a scores array to keep all the scores, and let's train the model. Initially, the maximum value was 0, the score was 0, and then started growing. And as you can see, with each iteration, the Q matrix, which is the new matrix, which is learning according to the paths which it is taking, is getting the maximum value 393, and the score is 100. And as you can see, we have the final Q train matrix. Now, with this, we cannot be sure which is the optimal path one should take. So for that, what we're going to do is, let's see how many iterations did it take to find the most efficient path. And let's see what exactly is the most efficient path here. So as you can see here, it took around 1,000 iterations to find the most efficient path, which is 0, 1, 2, 7. And as you can see here from this particular diagram, if we start from 0, we go to our initial step is 0 and the end goal is 7. So we go to 1, and then we go to 2, and then we go to 7. That is the shortest path one can take. Now again, if we try the new path, and now if we start from 0 to 6, this is an additional exercise for you guys. So if you want to know how many iterations it will take to go from 0 to 6, and what is the optimal path one can take to reach the 6th. So as you can see here, it will start from 0, then it will go to 1, then it will go to 5, and then it will go to 6. That should be the optimal path. But do check it out, guys. Do try it out yourselves. That's how you're going to learn. Now, the past year has seen a lot of great examples for machine learning, and many new high impact applications of machine learning were discovered and brought to light, especially in the healthcare, finance, the speech recognition, augmented reality, and much more complex 3D and video applications. Now, natural language processing was easily the most talked about domain within the community, with the likes of ULMFIT and BERT being open sourced. So let's have a look at some of the amazing machine learning projects which are open sourced. The code is available for you, and those were discussed in this 2018 to 19 spectrum. So the first and the foremost is TensorFlow.js. Now, machine learning in the browser, a fictional thought a few years back and a stunning reality now. A lot of us in this field are welded to our favorite IDEs, but TensorFlow.js has the potential to change your habits. It's become a very popular release since its release earlier this year and continues to amaze with its flexibility. Now, as the repository states, there are primarily three major features of TensorFlow.js. Develop machine learning and deep learning models in your browser itself, run pre-existing TensorFlow models within the browser, retrain or fine-tune these pre-existing models as well. And if you're familiar with Keras, the high-level layers API will seem quite familiar. Now, there are plenty of examples available on GitHub repository, so do check out those links to quicken your learning curve. And as I mentioned earlier, I'll leave the links to all of these open source machine learning projects in the description below. Now, next, what we're going to discuss is Detectron. It is developed by Facebook and made a huge splash when it was earlier launched in 2018. It was developed by Facebook's AI research team, which is FAIR, and it implements the state-of-the-art object detection frameworks. It is written in Python and has helped enable multiple projects, including the DensePose. Now we'll know what exactly is DensePose after this example, and this repository contains the code of over 70 pre-trained models. So it's a very good open source model, guys, so do check it out. Now, the moment I talked about DensePose, that's the next one I'm going to talk about. So DensePose is dense human pose estimation in the wild. Now, the code to train and evaluate your own DensePose using the RCNN model is included here, and I've given the link to the open source code in the description below. And there are notebooks available as well to visualize the DensePose COCO dataset. Now, next in our list, we have deep painterly harmonization. Now, I want you to take a moment to just admire the above images. Can you tell which ones were done by a human and which one by a machine? I certainly could not. Now here, the first frame is the input image, the original one, and the third frame, as you can see here, has been generated by this technique. Amazing, right? The algorithm adds an external object to your choosing to any image and manages it to make it look like nothing touched it. Now make sure you check out the code and try to implement it on different sets of images yourself. It is really fun. Now talking about images, we have image out painting. Now what if I give you an image and ask you to extend its boundaries by imagining what it would look like when the entire scene was captured. You would understandably turn to some image editing software. But here's the awesome news: you can achieve it in few lines of code, which is the image outpainting. Now, this project is a Keras implementation of Stanford image outpainting paper, which is incredibly cool and an illustrated paper, and this is how most research papers should be. I have given the links in the description below. Do check it out, guys, and see how you can implement it. Now, let's talk about audio processing, which is another field where machine learning has started to make its mark. It is not just limited to generate music. You can do tasks like audio classification, fingerprinting, segmentation, tagging, and much more. And there is a lot that's still yet to be explored, and who knows, perhaps you could use this project to pioneer your way to the top. Now, what if you want to discover your own planet? Now, that might perhaps be overstating things a bit, but the Astronet repository will definitely get you close. The Google Brain team discovered two new planets in December 2017 by applying the Astronet. It's a deep neural network meant for working with astronomical data. It goes to show the far ranging application of machine learning and was a truly monumental development. And now the team behind the technology has open sourced the entire code. So go ahead and check out your own planet, and who knows, you might even have a planet on your name. Now, I could not possibly let this section pass by without mentioning the BERT. The Google AI's release has smashed record on its way to winning the hearts of NLP enthusiasts and experts alike. Following ULMFIT and ELMO, BERT really blew away the competition with its performance. It obtained the state-of-art result on 11 NLP tasks. Apart from the official Google repository, there is a PyTorch implementation of BERT, which is worth checking out. Whether it makes a new era or not in natural language processing, we will soon find out. Now, AdaNet, I'm sure you guys might have heard of it. It is a framework for automatically learning high quality models without requiring programming expertise. Since it's a Google invention, the framework is based on TensorFlow, and you can build Ansible models using AdaNet and even extend it to use to train a neural network. Now, the GitHub page contains the code, an example, the API documentation, and other things to get your hands dirty. Now, trust me, AutoML is the next big thing in our field. Now, if you follow a few researchers on social media, you must have come across some of the images I am showing here in a video form. A stick human running across a terrain, or trying to stand up, or some sort. Now, that, my friends, is reinforcement learning in action. Now, here's a signature example of it: a framework to train a simulated humanoid to imitate multiple motion skill. You can get the code examples and a step-by-step run through. I've given the link in the description, so do check it out, guys. Now, with this, we come to an end of this machine learning project session. I hope you understood how exactly machine learning works, what are the various types of machine learning, how to code in supervised, unsupervised, and reinforcement learning programs, and what are the latest advancements of the projects which are available on the internet to get your hands dirty, and much more. So, guys, do check out every link I've given in the description, and each one of those projects is worth checking out, and I hope you might end up finding your own planet. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!